What's going on, guys? Vlad here with solosplc.com, and in one of the previous videos I talked about the MEQ, or the masked equals instruction, and this instruction is very useful in certain specific cases, but a lot of you have indicated in the comments that you couldn't understand the instruction and wanted to get a, I guess, more practical video on where this instruction might be used. So today I decided to go back and create a second part for the explanation of this instruction, because I do believe that there's some value in using this and understanding how it works, just from a general logic standpoint, but also in certain specific applications, like I've said. So without any further delay, let's jump into Studio 5000, and I've created this fairly straightforward program that you can play with if you want to download the code, and we're going to be going through step by step not only why this instruction could be applied here, but also some of the other ways that you can optimize your PLC programming code, make it a bit more efficient, and make it take up less space. Without any further delay, let's get started. Before we get started with today's video, we just wanted to quickly point out all the great content we've been releasing on the Solus PLC YouTube channel. And this includes industrial automation, PLC programming, as well as HMI development. And if you enjoy this type of content, we would really appreciate it if you could click the subscribe button as well as the notification bell in order to receive the latest and greatest content we will be posting to the channel. Alright, so let's discuss the logic, and in order for you to understand the context, is that I've worked for a number of years in this peanut manufacturing plant, and I saw a lot of different logic written by OEMs and third parties as I came in there. And essentially, this demonstration is going to show you why the masked equal can be applied and why it can simplify a lot of the different ways that people write logic essentially in an inefficient way. So what you have here in the first rung, as well as some of the rungs below, are a way to select a different recipe, and based on the recipe you're going to get different ingredients. So in this rung 1, as you can see, it toggles a valve for sugar, and these are just ingredients that I came up with based on a specific recipe, but you can think of this being applicable to maybe a brewery, any manufacturing plant really that uses batches, that uses certain ingredients in food. This is very, very common. Next, you have valve 0 confirmation. So this is, you have to think of a manufacturing facility in the sense that once you tell a certain valve to open, you do want to get a sensor-based confirmation. So I can toggle this right now in my code. But ultimately what it tells me is that when I request for sugar in my recipe, the valve that is going to provide me sugar has actually opened in the field. So think of this as just a digital sensor. Next, I have a valve for salt as indicated here, and then I have a valve for spices, so on and so forth, and I have a total of 6 valves. And as you can imagine, in a specific recipe you might have up to 100 of these different valves. I've seen dozens and dozens of these different configurations. You might even have several valves per ingredient, and different recipes will call for different things. And this is of course not limited to just valves. This could be motors, this could be many other devices, sensors that you're using. So it's very, very common to see this type of logic. Now, what's also very common to see is these checks where, for example, if the current recipe is 1 and the recipe, like I was saying, is 5, for example, then you would enable this valve. So only in those 2 recipes you would send sugar, and then you would send in recipes 1, 2, 3, and 6 salt. And then, for example, for spices, it would be recipe 1 and 3. So as you can imagine, certain recipes are going to have different ingredients, and based on these equals instructions, you're going to open and close different valves. Now, some of you may already notice that this might not be the most efficient approach, and we'll look at that in a second. But the other thing that we do need to confirm is, as I was saying, are these sensors, and sensors are extremely critical. You should not be able to start the system until the sensors have been confirmed. And of course there's many ways to do this, but one of the most common that you will see at a plant level for someone who's fairly unexperienced is this type of a rung, which still gets the job done, but we'll talk about the problems with this. So when valve 0 is requested to open and it is open, so this is getting you to practice your XICs, or we don't care about valve 0, we go to the next valve and we check for every valve. So essentially, if it's selected by the recipe and it has been open, then we are in good state. Now, what's interesting about this logic is if you want to add a certain valve to this logic, it's going to be fairly complicated. So you're going to have to create a bunch of these equals, and let's go through that process. So let's say somebody asks us, hey, let's add a new tank that's going to be delivering something else to us. You're going to have to start by copy pasting these equal signs. So let's say this current recipe, you're going to confirm if it's recipe 5 and let's say or recipe 6. Then we're going to open this valve number 7. Let's see here, I'm going to paste this in. Valve number 7, recipe 6. And of course, I am going to have to paste a sensor. So I'm going to check this sensor for this specific valve. And if it's actually open, so that's that. I also have to modify this rung. So imagine the amount of work that this takes. I'm going to copy both of these instructions. Let's see here. So this is going to be my valve 7 check. And then I'm going to paste this not selected, valve number 7. So you can all immediately see how error prone this method is. And that took me about 30 seconds, but I had to add an extra valve, and you can see how inefficient that process was. Now, how can we essentially implement this with a masked equal instruction? Now, what I'm going to show you is let's, instead of editing this rung, let's just create one below. So you have to start thinking, at which point do we say that the system is ready? Well, once again, here we're checking for valves that we care about and valves and those valves need to be confirmed open, and those that we don't care about, we really don't care about that their status. And that just that thought alone should indicate a mask equal instruction to you. So let's think. First of all, we're going to get an instruction here. So mask equal MEQ. So the source is going to be, once again, we're checking for valves to be open. So our source is going to be our valves. So valves. Another important point to mention is that the valves, it's not a Boolean array. Instead, it's a dint. So it's a double integer, and that's the only thing that's going to essentially work in this. Well, there's going to be a couple of different types, but the Boolean arrays are not going to work. Next, we have a certain recipe check. So I've already pre-created a check, but let's change this a little bit. So let's create recipe check, and this is going to be based on current recipe. So this is going to be an array of different recipes that's going to call the current recipe that we have selected. In this case, it's 1. So I'm going to right click this, create new recipe. And this is going to be an array of double integers. We're going to limit that to 10 of them, just so we don't have to create and spend a lot of time. But I'm going to create 10. And what are we comparing to? Well, we're comparing to the array of actually open valves. So remember, this is the status of actually open. So we want to see if the valve has been requested, if it is actually open. So let's see here. So this is going to be valves open. Valves open, like so. And as you'll see right here, this is 55 equal to this 55. For now, let's just ignore the mask. I'm just going to compile this really quickly, and let's just see how, and actually we shouldn't use this OTE on the same Boolean, so we're going to create that as well. All right, so let's look back at the different recipes. So I'm going to scroll all the way up within this routine, and I'm going to change this recipe to a 2. And naturally, if we scroll and look at that Boolean at the end, you'll notice that the systems are not ready. And let's look at the reason why. So if we go through this logic, and I encourage you to do this on your own, but ultimately we don't care about valve 0, we care about 1, but it is open and confirmed to be open. We don't care about 2, we care about 3, and we notice that here, here's the conflict. So we care about valve number 3, but it has not been confirmed open. And you'll also notice that, of course, the valves here is not equal to the valves open. But more importantly, so this is still on. And the reason why this is still on is because we have all zeros, which means that we do not care about any comparison within the mask equal. So essentially, it's just telling us that this 10 is not equal to this 55. But ultimately, we want to only care about the valves that need to be open for that specific recipe. And if we refer back to what we've created in these equals instructions, is how we can build that specific array. So let's I'm going to walk you through this, but essentially let's look at recipe number 1. And so for recipe number 1, let's just switch really quickly. So for recipe number 1, I can just look at the last Boolean. For recipe number 1, we care about valve 0, we care about 1, we care about 2, we don't care about 3, we care about 4, 5, and that's it. So we care about 0, 1, 2, 4, 5. Now, in order to build our array, I'm just going to click on the recipe check and monitor, and I will be brought to the array of the different recipes. Now, like I was saying, this was recipe number 1, and as I said, we care about 0, 1, 2, 4, and 5. I'm going to Alt Tab and let's just double check that. So 0, 1, 2, 4, and 5. Now let's build the second recipe as well. So I'm just going to scroll back up in order to select recipe number 2. And what we'll notice is that for recipe number 2, we care about which valves. So we care about 1, we care about 3, and that's it. So I'm going to tab again, and in recipe number 2, we care about valve number 1 and number 3. And so going back to this, you'll notice that, so let's correct this really quickly. So since we care about 1 and 3, and then we have only 0, 1, 2, 4, and 5 open, then the system is not ready. But now you'll notice that it's also not ready through the masked equal instruction, because once again, we care about 3, but 3 is not actually open. So let's scroll back up and correct this deficiency. So let's say we fix the sensor on a valve number 3. Let's see what happened. So immediately our 10, which is on the valves that we need to open, is compared to the valves actually open. But because of our mask, we're only checking for those 2 valves, and our valves are equal to the mask that we've selected, and even if the other valves that we don't care about are open or closed, we still check OK. So the system is ready to start in both cases. So this entire rung of logic can be replaced by this simple masked instruction. Now, if I want to change which valves are required for which recipe, you'll notice probably that I do need to, let's say if I want to change valve number 2, I would have to scroll all the way up here, and let's say I want to remove valve number 2 from recipe number, so from this recipe number 3, I would have to edit this rung, and I have to remove this, and that's valve number 2. Now, once we have the MEQ structure ready, all I need to do is, first of all, I can collapse these recipes, and just to make it easier for me to see, I can switch this to binary, I can expand my value just so it's a little bit easier for me to view this number, and I can immediately see that in recipe number 1, I have valve number 0, 1, 2, and then 4 and 5 open. In recipe number 2, I have valve number 1, and of course it's in binary, so it's 1, and valve number 3. And I can create similarly recipes very easily through this menu. So I can say, I don't know, this is 0, 1, 2, 3, so 4, 5. If I want them open, I'm going to type in these 2 ones. And here we have recipe number 3. If I need some different valves to be entered in a different recipe, I can edit them from here. Now, the next thing that can also optimize this program, and I hope you understand the MEQ. So essentially all it's doing is it's looking at the valves we have selected for our program. We're looking to compare that to our recipe, to the valves that should be or are confirmed to be open. Now, the other thing that we can optimize is instead of doing all these equals, we can do a simple move. So each instruction, instead of opening, for example, this 0 with these equals signs, what we can do is the current recipe can hold an array can hold a certain value of what needs to be opened. So instead of, let's say this HMI 2 is selected, well, that could be associated with a certain binary number. And when 2 is selected, we can do a little bit of a different logic. So let's take a look at that right now. So if 2 is selected, so instead of doing the selection through each one of these, I'm going to just do something like this, equal. So if HMI recipe selected, let's say it's equal to 1, instead of moving all that, I can just move one time here. I'm going to move a certain number, and we can play with this a little bit later. So this is going to be recipe number, and I'm going to call this, let's say, and actually I guess we don't need to do this. We could just move, let's see here. So we're going to move whatever's selected, recipe number. Let's do this dint 10 of them. And I'm going a little bit fast, and hopefully you can walk this through on your own, but this will become fairly clear in just a second. And this is going to be valve bits, let's say valve bits. And let's of course create that double integer, create. And let's look here. So valve bits are going to, and actually this can be moved into valves directly. Let's see here. So valves, we can move that directly into valves, but we do need to change the recipe number. So let's see here. So recipe number. So again, in terms of which valves to open, so we're going to remove all of these. In terms of which valves to open, just so we can stay consistent with the values, let's see here. So we're going to switch back into recipe 1, and let's just double check. I believe it was 0, 1, 2, 4, and 5. 0, 1, 2, 4, and 5. So we need to change that array to the same exact value. So let's see here. And we can actually copy the mask over, but let's actually do that. So for recipe 1, 2, this needs to be recipe number, monitor. So for 1, we need this. For 2, we need this. For 3, we need this. And it looks like we can just move the same number as the mask or as the other integer. So let's see, let's delete all of this. This looks good. Okay, so now we are telling all of our valves to open in an order based on what the recipe specifies. And so from this point, we can start verifying if the system actually works. And we can delete this run as well. Okay, so in our recipe for the first one, we're calling 0, 1, 2, 3, and 0, 1, 2, 4, and 5. And if any one of those, so this 3 is fine, but if we remove this 4, you'll notice immediately that the system is not ready because that recipe is being called for and it's going through the recipe check that we've set up ourselves in this mask. Now, if we toggle 5, the same should apply as well. But if we go to recipe 2, remember that recipe 2 cares for different valves to be open. So now it cares about valve number 3, but it doesn't care, for example, for valve number 4, valve number 5, and if I remember correctly, valve number 2. But it does care about 1 and 3. So if I turn off 1, then it starts caring. And if it turns on, and I can just essentially move this, put that here, and recompile. So this is just a simple example of how you can save a whole bunch of space, and you can even probably optimize these sensors since they're going to be coming in from input points in your system to essentially translate these bits into the integer that's going to be on the outputs to double check that they're working. So it's a very, very condensed program, as you can see here. We actually don't even need this anymore. So let's remove this. So recipe selected really it can go immediately here. Again, for visibility, you could use current recipe here, but we don't necessarily need this either. So whatever is entered on the recipe side, as you can see, we have a 2 here. You could put in a 3. This is all done within these 2 rungs, and we've had, I believe, up to 20 rungs at the beginning. And I see that logic all the time in different machines. And one of the easy ways to optimize this is through this indirect addressing, through MEQs, and through move instructions, which you've seen in previous videos. Hopefully that was helpful, and hopefully the masked equal instruction makes sense now. If you guys have any other questions, feel free to ask on the forums of solusplc.com. Thank you guys so much for watching my content. If you have any questions on this topic, make sure to leave them in the comment section below. And if you can spend 5 seconds of your time liking as well as sharing that video if you've enjoyed it, that would mean absolutely the world to me. And if you have any suggestions for the channel, what kind of hardware, software I should be covering, then make sure to leave that down there as well. See you next time. Take care. Bye.